Okay, so what's been going on with me is last week at my house, I lost connection to the internet. So I called about it and I'm going to have that fixed this week, I hope. But let's see. So if I haven't responded to your emails, I'm trying to get to those. You do have your test available on Canvas. Okay, so let me know if you have any issues with that. We want to do some notes today. I'm not going to make any homework right away. We're going to wait till Wednesday to make more homework. And yeah, this class is good. This class just has tests. So if you're doing your test, just work on that. You have some homework in the past. If you want to go back and work on your homework, let me know. I'll check on WebAssign after this afternoon. I forget that WebAssign sets it at 5 tries. So if you want more tries, just let me know. I can open things up. All right. So I made up kind of an intro, and then we have an example, and then we start a new section. So the intro, you don't need to take detailed notes, and I hope I explain it well enough, but this is kind of an idea I wanted to share with you. We're good to go. Oh, on the note of not having internet, I don't know how soon I'll get these meetings loaded. I'm going to try to load last week's meetings as soon as I can, and then we'll see how soon we can get these meetings up. It'll all work out, I'm sure. Okay, so our book doesn't really give full detail, at least so far, on what an integral is. So I'm going to try to break it down. Okay, so given a continuous function f. On an interval AB. We create a partition P. Okay, and the partition starts at A being x naught. The next value is x1, and we're going to show that x1 is greater than x naught. So next is x1 followed by x2 till you get to the end, which was x7 equal to b. A is x naught, b is x7. And then we've broken it up like this. We'll start drawing a picture. Okay, this partition has divided the interval into n subintervals. Okay, this divides the interval into n subintervals. each of width delta x. You know, and we're going to put what delta x is. Okay, it's a minus b over n. Okay, that's the width. And then we have a height of f of x sub I. Let's pause on that part. So we have our partition. And then you break this up and we create rectangles. Let's see. The subintervals have this width. Okay, that's good enough. Okay. We'll just draw the rectangle part. Let's go into a specific interval. Let's say the ith interval is x sub I minus 1 to x sub I. Okay, and then you pick a value, or I'm going to call it a tag in that interval. So pick a tag. In this interval. I'm going to call it x sub I star. X sub I with a star. So let's say this is x sub I minus 1 and this is x sub I, and I pick some value in there to create the height of the rectangle. And then we just fill everything under the curve with rectangles, getting smaller and smaller in width, and that will give us the full area. So let's write it down mathematically. Okay. Okay, we'll use our notation first. Okay, we've been doing this integral from a to b of f of x dx. And it's actually the limit as n goes to infinity. Of the sum of all of these rectangles. So let's say you've got one here, different heights for each one, depends on which value. Let's go over. As I get smaller and smaller, it gets closer and closer to the curve, and you get a nice area. So the sum as n goes to infinity from I equals 1 to n of f of x sub I star delta x. So your width times your height of the rectangle. And then infinitely many rectangles to get that full area under the curve. Okay, the whole reason why I brought this up is because we're talking about a rectangle and it's got a width, positive width, and height, also positive number. So when we shift everything to the side, we want to make sure we pick the right value, the y values as our width and our height. So let's work through that. Okay, so I kind of showed this to you, but we didn't work on it because I wanted to show this picture first. There we go. Okay. So find the area between two functions. First one is, well, I was kind of rushing last time, so we're going to back up. What it starts out as will be 4x plus y squared equals 12, and x equals y. Good. So we're going to solve this equation for x. Get x is negative 1/4. Well, let's just work through it. X equals negative y squared plus 12. X is okay, I think this is where I talked about a sleeping parabola, but just to be sure that we get the right graph, I used Desmos, and I don't know if we actually did this graph, but let's do it today. So that part's easy to sketch. It's this part that I'm going to make sure I get right. We'll do it together. Oh no. Huh. Okay, well, for me, it's not loading. Well, I know what it looks like, and of course, just side note, you can always check your graphs with okay, let's draw this. So we've got the point 3, 0, and then up and over through the point, let's see, 1, 2, 3, 0, 1, 2, 3, 4. It's 1, 2, 3, and a little bit. It's 3.46 is the actual place where you cross the Okay. Sorry, you guys. I don't know if I've mentioned it to this class, but I live in Nevada County, which is kind of in the mountains. We don't have very good internet access, even wherever I try to go. Anyway, okay, there's a 0.0, 3.4. It's 3.46. 1, 2, 3, and a bit. 0, negative 3.46. That was one function. The other function is the line y equals x. And I have a note of where they're going to intercept right here. Okay, so when negative 1/4 y squared plus 3 equals y. Okay, I multiplied everything by 4 to get rid of the fractions. Okay, this equal to 0. Let's just add y squared. And then factor. Let's keep this picture. Okay, I got y plus 6 times y minus 2 is the factored form. Okay, so y equals negative 6 and y equals positive 2. So on the y-axis 2, and then over to this graph is where I'm going to make a mark. Then here we're going to go down to negative 6. I'm going to have this smooth a little bit more. Okay, so we went down to negative 6. Let's see. 1, 2, 3. Oh, that was a different part. 4, 5, 6, and then kind of over. It looks a little bit too far up. Maybe you have a better sketch. I'm just going to go ahead and draw this other line. So through this point, through the origin, through that other spot I marked, and it keeps going. We want this area here. Okay, so let's try drawing the rectangle. It's going to have a width of change in y, delta y. And then we want the height to be a positive number. So we'll talk about that in a sec. So we've got a graph and we did that part of the graph. Okay. So it'll just be a matter of making sure that you get the right top function and then subtract the correct bottom function in a way that you get a positive height. So we're integrating from y equals -6 to y equals 2. We're going to have a change in y. So let me just make sure I get this right. So I have that this is the top function. So if we have this function and subtract the other function, let's see, whatever x value this has, the x value for the function here is less than it, so we'll get a positive number. Let me write it down and then see if I can talk through it one more time. We're going to have this function. Subtracts the other function. Let's say like even on this rectangle, this x value would be a negative number, and this would be a positive number at the other end. So we'd want to have, we wouldn't want to do negative number minus more. You want to have this positive number and take away that other negative part. These were always tricky for me to explain as a tutor, and I'm not going to put too much of this on your homework, but I think we can still just, we've done our best to set it up. We can finish the problem. Maybe we'll try this again another day. Okay, so if the setup was the hard part, now we just do the integral with respect to y. All right, integrate from -6 to +2. Negative y of this. It's just something that we can do. Let's just go on, integrate. -1/4 y to the 3rd over 3 plus 3y minus y squared over 2. Evaluate from -6 to +2. So negative y cubed over 12. And let's see. I did put everything in. So first we'll put 2 into the full expression. So I'm going to set that sign. A negative of 2 cubed over 12 minus 3 times 2 minus 2 squared. Subtract. Put in -6. Negative of -6 cubed. Okay, let's see. I'll just write down all the scratch work I have. We've got time. So this would be negative, oops, here, -8/12. minus 6 minus, what's this, 2. Uh-oh. I think that this got, hopefully, shoot, I hope this mistake hasn't been happening for a while, but this was supposed to be a positive sign. This is a plus. I have that it's negative y cubed over 12 plus 3y minus y squared over 2, and then evaluate. Okay, this sign changes. There, here. Okay. Subtract. What's that? 6 cubed over 12. 18 says plus, or no. Another 18 at the end. That would be negative, but then it becomes positive. Yeah. 18. Okay, let me know if you see any mistakes. All right, next. I've got that this part, negative 18 right here. And then I got a fraction. So I wrote it as, let's see, well, I put 22 minus 8/12. And I got 256 over 12. Okay, so when I do make homework, which will probably be Wednesday, I might put 1 or 2 problems where you integrate with respect to y, but mostly we'll just have functions where it's integral from a to b of the top function minus the bottom function with respect to x. Okay, let's wrap that up. Move on to something new and also something kind of fun. So this section is 6.6. Okay, so we're gonna do discs and washers. There is one more thing that I learned about called shells, but that's not gonna be in our book. So you could do discs and washers and shells. We're gonna focus on discs and washers. Okay. So some volumes of familiar shapes. Okay, the volume of a rectangular box. Which we will draw on the side of this. Let's do length and then width, height. Length this way. This is the width. And then here is height. volume is length times width times height. And I put one more, A for area, so area times height. Okay, the volume of a cylinder Okay, it's my cylinder. I'm going to draw a radius, this little radius R right here. Okay, volume of a cylinder is B equal to this area pi r squared times the height. Or again, I'm going to put area times height. Okay. Let's try this. We're going to do this. Volume equals the integral from a to b of a of x dx. A of x is the area of a moving cross section. Obtained by slicing through x and perpendicular to the x-axis. And okay, so the area of a slice at any little point, like any value of x, and again, perpendicular to the x-axis. Okay. First, we focus on discs. So we're going to show that the volume of a sphere of radius r is 4/3 pi r cubed. Set a quick timer so I don't keep you too long. We get out at 1:50. So we'll draw a sphere, and then we're going to draw a slice and set up our integral. So picture this. Actually, let's go ahead and clean that. Okay, that's a little bit of drawing, so a little bit of cross hatching maybe, just like swoosh, swoosh, a little, it's supposed to be round. Okay, and then we're going to take a slice. So I'm going to draw kind of like this. Over and down. Okay, that's my disc. Right there. And let's see, I've got that radius of the disc, R, is going to be right there. Here to here. And then from the Pythagorean theorem, you can draw a like rectangle here, come down to the origin, and this like x value and this y value can go into the equation. Let's see, x squared. What is this? X squared plus y squared equals r squared. Oh, I'm sorry, I've labeled this wrong. So what this is, that height there, that's y right there. Yeah, so this comes up to here and over to y. So that is y. And then r is the radius of the sphere. So from the origin to the edge of the sphere, that's r. Okay, there we go. X squared plus y squared equals r squared. Okay, I solved for y, actually for y squared. And then I wrote that the cross-sectional area is a of x, and it equals, let's see, pi times y squared. Like pi times the radius squared. The radius of this slice was y. And we've solved for y squared, so it's pi times r squared minus x squared. Okay, so now we can do the volume of the sphere. Let's see, I go from negative r to r from the far edge of the sphere as your x value is negative r. The bias to x can go as positive r of pi r squared minus x squared dx. Cool. We'll definitely finish this one. So we just integrate like we've been doing. See, I guess I didn't need to do that really. So just want to make sure that I integrate with respect to x. So this is going to be x r squared minus x cubed over 3. All right, so we put in r, pi times r cubed minus r cubed over 3. Take away putting in negative r. So when you put in a negative r here, it's going to get squared. Wait, sorry, is it negative r for x? Let's just be careful in this. Negative r times r squared minus negative r cube it divided by 3. Close that. And it was all multiplied by pi. Okay. R cubed minus r cubed over 3 minus negative r cubed. Okay. That would be negative r, and then this makes it positive, and then this makes it negative r to the third over 3. Make sure I have that right. Okay, those go together. And let's see, that one too. Hang on, where are we at? Still have pi. Negative 2r cubed over 3. And then r cubed over 3. That's what it was. Those there. Let's get a common denominator. So 6r cubed minus 2r cubed is in the numerator. It's 4r cubed. Or like we had earlier, 4/3 pi r cubed. Nice. Okay, let's end there today. I have like a handful more where we're going to do discs, and then I've got a couple of the same style, but where we do washers. And then I think we'll be done with chapter 6. All right, have a good day, everyone. Please